pre-algebra class. This is our video for lesson 99. We're talking about inverse variation today. So most of what we've been talking about with variation has been direct variation, okay? As our x value increases, our y value increases, okay? Today we're talking about inverse relationships, okay? In a direct variation, to find our constant, we use this formula, y over x equals k. To find the quotient of the two variables would give us our constant. Okay, remember when we had our x and y chart, we would take y and divide by x, y divide by x to see if we get the same constant every time, to see if it's a direct proportion. Okay? In an inverse variation, it's the product of the two variables that give us our constant. X times y gives us our constant. Okay, so in your book, on page 659 at the top, it gives you this scenario where you have a loaf of bread. Okay, so you've got this loaf of bread. If there are two of you, and you're going to evenly divide the loaf of bread, then you each get this much bread, right? But what happens if you increase the number of people that are going to get the bread? If instead of 2 people eating the bread, it's 4 people, and you're each getting an even slice, then your slice of bread gets even smaller, right? And if there's 8 people, if the number of people increases even more, the size of your slice decreases even more, okay? So as the number of people eating the bread increases, the size of your piece of bread decreases, okay? So they're showing an inverse relationship there. I'm going to use a pie to show an inverse relationship, okay? So think about if you have a pie for a holiday or something, and 2 people are going to eat the pie. Think about how much pie you get to have if you're going to evenly split the pie. You get half a pie, right? But if 4 people are going to be eating the pie, each person doesn't get half, they only get 1/4. So our slice of pie is getting smaller. If 8 people are going to eat the pie, then each person gets 1/8 of the pie. As the number of people eating the pie increases, the size of our slice of pie decreases. Okay? Inverse relationship. So let's think about it this way. If we're going on a trip and we average 60 miles an hour for the 180-mile trip, the trip takes 3 hours. We want to determine the time the trip is going to take if we travel at these other rates. Okay? So at 60 miles an hour, 180 divided by 60 gives us our 3 hours. Okay? Or we could say 60 times 30 gives us our 180 mile trip, rather. Okay? So go ahead and figure out how to, or figure out the time it's going to take if we're traveling these other rates. Pause your video, complete this chart, and then start it back up again. Okay? So when I did my calculations, if I'm traveling 180 miles at 40 miles an hour, the trip was going to take me 4.5 hours. At 30 miles an hour, the trip takes 6 hours. At 20 miles an hour, the trip takes 9 hours. Okay? What is the constant in this problem? What is the thing that's not changing? It's the 180 miles. I still got to travel 180 miles no matter what rate I'm going, and the rate determines how long the trip takes, so the thing that's not changing is our 180. So we can think about rate times time equals our distance. D is the constant. It's the thing that's not changing, the distance. Okay? So if we're thinking about this, how long will the trip take at 90 miles an hour? Please don't go 90 miles an hour, but if for some reason you were thinking about how long a trip would take at 90 miles an hour, how long would it take? 2 hours, just giving us another value, okay? Because on the next slide, we're going to graph these values, and we're going to look at the graph of an inverse relationship, okay? Okay, so on this graph, I'm going to have time be my y-axis, and the rate that I'm traveling be my x-axis. On my x-axis, I'm going to go by tens, 10 miles an hour, 20 miles an hour, 30, okay? And on my y-axis, I'm going to count by 1 hour at a time. Okay, so at 60 miles an hour, it took 3 hours, right? 10, 20, 30, 40, 50, 60, 1, 2, 3. So that gives me a point here. At 40 miles an hour, it took 4.5 hours. 40, 1, 2, 3, At 30 miles an hour, it took 6 hours. 1, 2, 3, 4, 5, 6. At 20 miles an hour, it took 9, 6, 7, 8, 9. And then our last one we did at 90 miles an hour. 60, 70, 80, 90 took 2 hours. Okay, so let's think about what this, go ahead and just connect these points here and think about what this looks like. Okay, very different from a direct variation, right? Okay, so let's think about what's happening. As my x value increases, look what's happening to my y value. It's getting lower, right? And then if I think about it this way, as my y value increases, the x value is getting lower. Okay? So this is the typical graph of an inverse variation. Okay? The typical graph of when we have x times y equals our constant. Okay? Now let's think about one other kind of inverse situation. 5 people on a painting crew take 20 hours to complete a job. Okay? 5 people on the painting crew take 20 hours to complete a job. So that means 5 people times their 20 hours gives us 100 people work hours, right? People / work hours. 100 person work hours. Okay? If only 4 people can work on the job, how many hours will it take to complete it? So we are reducing the number of people. Okay? So think about in an inverse relationship, if I'm decreasing the number of people, what's going to happen to the number of hours it takes to complete the job? Okay? To equal our 100 people work hours. Hopefully you figured out. It's going to take 25 hours. Okay? So if we're reducing the number of people working on the job, it's going to increase the number of hours it takes to complete the job. Okay? Okay. I want you to pause your video, do your practice set A through G, okay? And then start it back up, and we'll answer the practice set. Okay, so on A through D, they ask you to decide if this is an inverse or direct variation. Okay, so A was direct, okay, because the formula for giving us our constant was the quotient of the variables. B was a direct relationship because the constant is found by the product of the variables. C is a direct variation. As x increases, y increases. D is an inverse relationship. That's the kind of graph that we just discovered with an inverse relationship. Okay? E says on numbers 1 and 2 there, determine if these charts show an inverse relationship, inverse proportion. Okay? Number 1, yes, it is, because the products of the variables is constant. X times y gives us a constant. 1 times 6 is 6. 2 times 3 is 3. 3 times 2 is 6. 1 times 6 is 6. 2 times 3 is 6. 3 times 2 is 6. We get the same number each time. We're getting a constant. On number 2, it's not an inverse proportion. 1 times 3 is 3, but the second pair, 2 times 2, is 4. Got a different number. So we're not getting the same number each time when we multiply the variables. Okay? F. On F, it takes 3 people 5 hours to complete the job. How long would it take if I had 5 people? So I'm going to increase the number of people from 3 to 5. So think about what that does to the number of hours to complete the job. Okay, so now it's going to take 50. This should be over here. N is equal to 3. So if I have 3 people, it takes them 5 hours to complete the job. But if I raise the number of people, then I shorten the number of hours to complete the job. It only takes 3 hours to complete the job. G, the volume of air in a balloon and the air pressure in the balloon are inversely proportional. If the balloon is squeezed to half its original volume, so I've reduced the size. So if it's an inverse relationship, what have I done to the pressure? Okay, if I'm reducing the size, it's going to increase the pressure. Okay, I've reduced it to half, so the pressure is the inverse of half, which is 2. Okay, so the answer to G is 2. Okay? Okay, so think about that. Half, that's our X and our Y. Instead of using it as a quotient, we want to use it as a product. The constant is 2. Okay? Okay, so go ahead and complete your assignment for lesson 99 today. Okay, I hope you guys have a great day, and I'll see you next time.